All right, so if you've been trying to speed up your GitHub workflows without having to pay an exuberant amount of money to GitHub for, let's be honest, their old and slow instances, let me introduce you to Runzon. So Runzon is a fully self-hosted solution on your own AWS account that uses EC2 instances to run your workflows and takes full advantage of all the capabilities AWS provides us so that we can get the best performance at the best price possible. And the fastest way to get started with Runzon is to use Runzon Flex. So let me show you how that works. So here we have a very simple workflow that uses a test and a build job. And if you see here, we're using Ubuntu latest as our runner, which will change to an equivalent Runzon instance, just like that. So in this case, we're using a general purpose EC2 instance of the M8A family with like 2 CPU cores and 8 gigs of RAM running on Ubuntu. So this is equivalent to an actual Ubuntu latest instance, but newer and faster, of course. So just like one line of change and we can just get started on Runzon. So let's just run this job and see. All right, while this runs, let me show you how easy it is to install Runzon as well. So it's just a few clicks and you can get started with either CloudFormation or Terraform. I personally use Terraform and it's as easy as cake to get started there. So let's get back to our workflow here. I'll have the docs link in the description, of course. So yeah, our test job ran. And if we take a closer look at this step, yep, we got an M8 AZN large instance, 2 cores, 8 gigs, and a spot instance. So Runzon uses spot instances by default so that you can save even more on the instance you use without having to compromise on the performance. And I think our build job also got the same instance. Yep. So yeah, as easy as cake, right? So let me show you how flexible Flex actually is. Going back to our YAML file here. So for example, if you wanted this job to be, or if this job was supposed to be a bit more memory intensive, so if it needed a lot of RAM, for example, but you didn't need to care about the CPU count, or you wanted to reduce the amount of CPU cores that your instance actually use so that you can save up on the price or like not waste CPU instances. So in that case, we can use a memory optimized instance, which are the R family of instances. So we just mentioned R star here. So this will let Runzon know that any R instance would do. We'll chuck the CPU constraint out and use a 16 gig of RAM, for example, a 16 gig instance you need. And that's it. We'll just run the job and Runzon will take care of it on its own. Pretty simple, huh? Yep. So, yep, we got an R5A large. And yeah, we got a 2 core CPU, but 16 gig RAM instance. So, pretty flexible, right? So, let's go a bit further, right? Back to our. All right, so if you see here, I've added a pretty hefty label for our build step here. So in this case, we're using an M8 star family or any M8 family of instance that we don't care which one. And we've also added a range for our CPU and RAM constraints. So a CPU between 4 and 16 cores and a RAM between 8 and 64 gigs. And we've also changed the volume. So if you want to change the volume and its own specs, you can do that as well. So we've increased the volume from 30 GB to 100. So a typical Ubuntu instance uses 30 GB by default because that's how much the image needs to run. And we've also increased the throughput to 500 and the IOPS as well to 4000 IOPS. So we'll just run this and see what Runzon chooses for us. All right, so our build jobs has started to run. And if you look here, okay, we got an M8i X large in this case. 4 cores and 16 gigs of RAM, so well within our range, and again a spot instance. So this is all, and we can't check the throughput of volume here, but we can see that okay, we got a 100 gig um, EBS volume here for the EC2. All right, so you might be thinking this label is too long to read and to maintain, and it could get longer because we've got a lot of options to configure runs on. So there's going to be many more constraints that you can add here. So the best way to get over that is to create a global file that defines your runners in one place in a YAML file, and you can easily define all the specs with all the ranges here. So in this case, we've added a build and a test runner, and we've mentioned all the families we need for the build, the range for the CPU and RAM constraints, and the volume specs as well. So for test specifically, we've chosen a lowest price spot strategy. So AWS provides us with three kinds of strategies to to capture spot instances. So a lowest price, a balanced one, and a more capacity optimized. So a capacity optimized strategy would be to prefer the capacity that we ask for, even though we have to wait a little bit, but we'll for sure get it and not get interrupted. A more balanced take is okay, you might get interrupted, but you will get a more balanced instance in terms of capacity and price, and lowest price is of course the cheapest. So in this case, for test, we don't need a lot of performance, so we'll go with the lowest price. So let's use these runners. I think I've already added this in. Yep. So I think I've got it mixed up here. So the test job uses the test runner and the build job uses the build runner. And that's it. We just use those, commit this, and run the job. All right, so our test job started to run. So if you see here, it shows a T3 medium spot instance because we asked them to choose the cheapest of all the options that we provided. And it went ahead and chose the cheapest one within the range of our constraints for CPU and RAM. And the same goes for build, which will start running in a few seconds. Yes, so since we didn't provide any spot strategy, it will go with the balanced one by default. So C7AX large in this case with 4 cores and 8 gigs, which is also within our constraints that we defined in our YAML file. So that's it. That's a very small part of how runs on Flex works. We've got a plethora of options for you to choose when it comes to using all capabilities of AWS and EC2 instances. So check out the docs to know more, and I'll see you soon.